track thousands of objects around Earth to make sure nothing collides. But for Artemis II, we do not actually have public data to do that. So the question is, how would we know if something was on a collision course? Hi, I'm Dr. Amanda Fetch, aka Dr. Amanda Analytics, and my research is focused on AI and space situational awareness. I'm going to show you what data actually exists for Artemis II and how you can find and read it yourself. So if you want to follow along, you can navigate to NASA's website and search for Artemis II tracking, or something along the lines of the Artemis Real-Time Orbit website. This is the main dashboard. From this snapshot, we can see about 6 days and 19 hours into the mission. Around 1,900 miles per hour, about 195,000 miles from Earth, and about 88,000 miles from the Moon. So what does that tell us? It tells us Orion has already traveled most of the way to the Moon. And based on the distance trend, it has already passed the flyby and is now moving away. One simple way to tell this is to watch the distance to the Moon. If that number starts increasing, the flyby already happened. In Earth orbit, we use shared tracking systems to monitor objects and prevent collisions. But in cislunar space, there are spacecraft out there, like for example, NASA's Lunar Reconnaissance Orbiter and South Korea's Denori KPLO. But we do not have the same kind of shared tracking system. To understand why this happens, you can navigate to the NASA Scientific Visualization Studio and search for Artemis II trajectory. You will find visuals similar to what I'm showing here on the screen now. Now this is called a free return trajectory. Loops around the Moon and naturally brings the spacecraft back to Earth. This is where it starts getting interesting. Artemis II is flying about 5,000 miles above the Moon. Compare that to Apollo, which was about 68 miles. So Artemis II is not orbiting the Moon necessarily. It's performing a distance flyby. You will also see third-party visualizations floating around out there. One, like the one I'm showing now on screen, artemistracker.live, these are built using mission data and trajectory models, but they are still based on the same underlying source and not independently verified in its tracking like we see through Earth's orbit. And so when I'm speaking about this, I'm talking about some of the data sources I had used in my previous research and videos, such as spacetrack.org. Now, if you want a real mission to compare against, you can navigate to NASA's Apollo mission page. Now, from this example, orbit altitude was about 118 miles, total distance traveled was about 579,000 miles, and the mission duration was about 6 days, which is similar to about where we're sitting now, a little over that, a little closer, I'd say, to about 7 days. So Apollo missions were much closer to the Moon, shorter in duration, and operating in a very different profile. Now in space situational awareness, we normally validate objects using multiple data sources. But for Artemis II, we are relying on a single controlled view of the mission. So what you're seeing here is not raw tracking data. It's a simplified view designed to help us understand what is happening. So once you're familiar with how to read this, you're not just watching Artemis II now. What you're actually doing is following the mission as it unfolds. So I have a question I'd like you to think about, and perhaps leave your thoughts in the comments. If this data, mission data and beyond, was available publicly and not classified, what kind of data would you want to analyze? And how do you think it can assist us in future missions? Would love to hear your thoughts in the comments. Thanks for tuning in. Take care.